This episode of the HVAC School podcast is made possible by our sponsors, the Carrier Corporation, Testo, and RectorSeal. I want to remind you that my favorite set of digital gauges, and this has been true for many years, is the Testo 550. Just what you get for what you pay, and the quality of the product is really unmatched, and that's been true for many years, and I'm going to highly suggest that you look at the Testo 550 if you're in the market for a digital manifold, and the best way to do that is to go to TrueTechTools.com, and if you're interested in purchasing it, use the offer code or coupon code, if you want to call it that. Get schooled at checkout for a great deal. Also, thank you to our new sponsor, RectorSeal. If you don't know, RectorSeal makes a lot of products that you probably already use, like the Kickstart hard start kits that use a real potential relay and a real start capacitor. The Safe T-Switch products, the SS1, SS2, SS3 are sort of the staple products that exist out there in the marketplace, and the products I have on my shelf. Products like True Blue thread sealant, which truly is a better thread sealant than a lot of the other brands that you're going to see out there. There's some brands that are also blue thread sealants, and I prefer True Blue to those products. But more than anything else, I want to thank Carrier, Testo, and RectorSeal for partnering with this new wave of making technician training free to every technician and apprentice out there who's interested in pursuing the trade. Like I've said many times before, what we produce is for professionals or those who are interested in getting into the trade. It's not low enough fruit that a homeowner could use this information. We are doing this for those in the trade to help fill the skills gap and take those who are new in the trade, or maybe even those who are experienced and have forgotten some things. Get them the skills, get them the knowledge that are really going to help them. This is not a replacement for doing the hands-on work, but companies like Testo, Carrier, and RectorSeal who get the direction that the industry is going and have partnered with us, they get it, and I really appreciate it. Hey, thank you for listening to the HVAC School podcast. I am Bryan, and today's episode is about brazing and HVACR pipe fitting. We're not going to talk about soldering today. There is a case being made for some products for soldering and HVACR, but today we're not talking about that. Although some of this will apply, we are talking specifically about brazing. But before we do anything else, before we go any further with brazing, I do need to talk about safety. And there are some, I don't talk a lot about safety here because there's a lot of training out there that does a better job. I tend to focus more on the technical. But in this subject, brazing, safety is totally central to the whole endeavor. And so the first thing is, whenever you're going to be working with equipment that creates fire, you want to make sure that you know your gear. And so if you get a new set of gear, you want to make sure that you read all the instructions and you understand it really well. I'm not going to talk about the very basics of how to use a regulator, for example. So you want to know those things. And you want to make sure that your hoses are in really good condition. You don't have any cracks or anything that's been crushed or damaged on your hoses or on your regulators. You don't want to have a regulator that the dial is falling off. I see this all the time. So the first step is just to make sure that your gear is in really good condition and that you understand it. You understand how it works and you know exactly what you're doing. That's the first thing. So don't pick up a oxidizing torch kit, which is, by the way, what we're talking about here primarily is oxidizing. There are other setups, but that's primarily what I'm going to be talking about here. Is the most common, which is oxidizing. So you need to make sure that you know what you're doing before you get started with this. The next thing is make sure that you have safety glasses on when you're brazing or soldering. So have your safety glasses in place that cover not just in front of your eyes, but around the edges generally is a good idea as well for most basic brazing and HVACR. And then also make sure that you're wearing gloves, protect your hands, protect your arms. Just make sure that everything is well covered. Whenever you're going to be brazing, it's a good idea to have some damp rags near you in case something were to ever get out of hand. Say you burn yourself for some reason, have some rags there. Or if you need to handle something quickly, having some rags is always a good idea, damp rags. And also, as we're going to talk about later, you want to be able to make sure that you're not going to damage whatever it is that you're brazing near. So just having some damp rags handy, and maybe even a little bit of water is a good idea. And then in addition to that, you want to have a fire extinguisher handy. So anytime, really no matter what you're working on, there's always the possibility something could catch on fire, especially when you're inside a space. You want to have a fire extinguisher handy. Obviously, I'm not talking about cases where a fire spotter is necessary. That's a whole nother deal. And in some cases, that may be the case. So you do need to think about the application location. Where are you working? What are the conditions around you? And make sure that you're following all the best practices related to the situation that you're brazing in. But in general, if you're working in a typical residential environment or light commercial environment, you really just need to make sure that you have a fire extinguisher, you have in your proper safety gear, you understand your brazing rig, and make sure that it's in great condition before you get started, and have some wet rags and maybe some water handy as well. You also want to make sure that you have, if you're going to use, channel locks or something to handle some fittings, you want to make sure that all of that's ready. Anything you're going to need to do the handling, you have that all ready and in place. One other consideration is just make sure that if there is a fire system or smoke detection systems or those sorts of things, that you've taken into account where they are and what how you're going to deal with the situation. If you have a fire sprinkler system, obviously you have to be super careful. You have to make sure that you're not going to trigger a fire sprinkler system or an ANSEL system or something like that when you're working in commercial environments. So be very, very careful. And if you have those sorts of considerations, you want to be very diligent to talk to the customer and make sure that you take all of the proper precautions, which I'm not going to go through what all of those are right here, but you need to make sure that you're paying attention. Even a residence, just regular smoke alarms, you're going to want to make sure that you have those addressed. So either covered or maybe the one closest to where you're going to be working removed temporarily, and have a conversation with the customer, letting them know that there's always the possibility that it may go off. And in those cases, you want to make sure that you are well protecting the space. So if you're going to be working over carpet or something, it's a good idea to put down some metal sheeting or the panel of the unit or something anywhere that there could be any possible solder drips or anything like that. You just have to really, really think about the space that you're going to be working in, and be extra careful to make sure that you're protecting that space. Another thing that I think I need to state that is not directly related to brazing, but it is the idea of unsweating something, so of heating up a fitting and pulling it apart. In general, that's just a really bad idea. You should only unsweat something if it's an absolute must, because anytime you unsweat a fitting, and there's always the possibility that pressure is building up, even if you have the system open, and so that way it can escape. There's always some pressure buildup at the actual point of heating, and then also the oil will often catch fire. The refrigerant oil will catch fire when you pull it apart. So I generally recommend not unsweating. And then also, whenever you unsweat, let's say you're unsweating near a dryer or something of that nature, you can often release moisture into the system by doing that. So in general, it's better to cut things out of the system than it is to unsweat. If you do need to unsweat, just make sure to take extra careful precautions that when it comes apart, if oil does catch on fire, it's not going to damage something, drip on something, damage wires, burn you, all those sorts of things. Just make sure that you're in a really good position, well ventilated. Also, obviously, phosgene gas is a major consideration, the burning of refrigerant that lets off poisonous phosgene gas. And so unsweating is always something to be really, really careful for. Even when you're brazing something in, you can have these types of conditions that can occur. So you always want to make sure that the system is open to atmosphere so that pressure can be relieved to atmosphere, which goes into what we're going to talk about in a little bit about the flowing of nitrogen while brazing. So once you know your gear and you have everything set up and you've got your safety gear on and you know the space that you're in and you make sure that you've taken all the proper precautions, now it's time to actually think about what are some of the best brazing practices, the actual doing of the work. So the first thing is, and to me this is probably one of the most important factors, is that whenever you're working with copper lines, refrigerant lines, you want to make sure that you're keeping stuff out of them. And so some of these practices that we're going to talk about, or whether it's using flux, which today we're not going to talk a lot about that, but if you were to use flux, or if you're reaming out copper, deburring the copper, these are all opportunities for stuff to fall in the pipe. So whenever you're working with copper, you need to make sure that you're not letting stuff get into the tubing. So this is an example. An example would be if you're using sandcloth or emery cloth to clean the copper. That's an important practice, something that you should be doing. But when you do that, are you letting those little pieces of the copper fall into the tubing? Are you letting that dust get into the tubing? So you have to be really thoughtful about that. And when you're reaming and deburring copper, you want to make sure that you're holding it upside down to ensure that those little pieces of copper aren't falling into the pipe, which is something that I want to address. I'm a big fan of reaming and deburring, so using an actual reaming tool, reaming out the inside of all of your copper tubing after you cut it. That helps make sure that you're running the full diameter, and it also leaves a smooth edge so that way you're not creating turbulence in the lines, or if you're creating flare fittings, for example, it helps you make a proper flare. So that's an important thing to do, but If in doing so you drop some copper shavings in the tubing, it would have been better that you didn't do it in the first place. And the same thing is true of cleaning the copper with emery cloth or sandcloth. It's important to do, but if in the process of doing it you're being sloppy and not careful and you're contaminating the copper, you're getting solid contaminants in the copper, it would have been better that you didn't do it in the first place. So whenever you're prepping your copper, prepping fittings, using flux, reaming and deburring your copper, you want to make sure that you're being really careful to not get anything in it. And I see a lot of guys who will, kind of blow in it or do those sorts of things. Well, I mean, that's not a technical way of doing that, besides the fact that, blowing in copper with your breath and spittle isn't the best practice. So it's better to make sure that you don't get it in there in the first place. And one of the easiest ways to do that is when you're reaming, deburring, cleaning, to hold the copper with the open end pointed down so that nothing gets into it. But when it comes to preparing copper and we're talking copper to copper here, which is really what I'm going to focus on. We're going to do a whole separate, this is a basics podcast. We're talking the basics of brazing. So we're thinking copper to copper here. You want to make sure that you prep the copper in such a way that it's clean and that it's very tight. So we've probably all seen situations where a technician will take a suction line and insert it into a condenser, and the condenser suction line's too large, and so they'll take it and they'll just pinch it down and solder it. Or braze it. You don't want to do that. You want it to be a nice tight fit, and if you need to use bushings or reducers in order to get it a nice tight fit all the way down, then do that. Or in some cases, have I used different diameters of copper in order to create my own field reducers, and maybe a swedge tool in order to make those reducers? Sure, and that's okay, but you want to make sure that it's being reduced all the way down and that you're reaming, deburring, and cleaning the copper at every stage, so that way you've got nice, tight, clean fits with everything all deburred, so you don't have that little edge on the inside that creates turbulence in the refrigerant. Because really what we want to have is we want to make sure that we have a really good seal. We're really making sure that we're sealing it well when we braze, and that also the inside diameter of that copper isn't compromised. And what can happen, and I saw this one time with a compressor, somebody took a compressor and they installed a discharge line that was smaller, and they attempted to just bridge that difference in size. So you had the female fitting on the compressor, and you had small diameter copper discharge line going in, and they just attempt to bridge. What happened is the solder was pulled in to that, the rod was pulled into that fitting, and it actually blocked the discharge line partially, which caused all sorts of weird, hard to diagnose problems because the compressor wasn't producing the capacity that it should, and it was overheating, and so on and so forth. So you don't want to create bridges with solder or brazing rod. That's not what you want to do. You want to make sure that you have nice tight fit all the way around. And keeping some various size of reducers and fittings and different size tubing of copper, and having a good quality swedge tool on your truck. I recommend a lever or hydraulic swedge. Is going to be a really good step, a nice way to be able to create reducers when you need them, as well as making sure that you have a good reaming tool. The reaming tool that I like is the one that you actually insert into the line and you kind of spin it around. It's not the triangle ones that you see on the typical tubing cutters. Those I don't have great luck with, but the ones that have the handle and then it's got like the little scythe looking, curved blade on it that you actually twist around in the pipe, in the tubing, I've had really good luck with those. So once you get all of your tubing fit very tight and it's nice and clean, it's been cleaned properly, what I generally do when I clean it is I'll use a sand cloth, an emery, like a mesh emery cloth, clean it real well, and then use a dry microfiber rag to clean off any of the dust that's gotten on it before I fit it together. That's a nice way of doing that. But once I get everything kind of all together, now the next phase before I start to actually set up my torch kit for brazing is going to be to start flowing nitrogen. But before I even flow nitrogen, I need to purge with nitrogen, which is an important step that sometimes gets missed, because when you've had a system that's open to atmosphere, you not only need to flow nitrogen through it, but you need to initially get all of the air, all of the atmosphere refrigerant out of it, so that way it's only nitrogen going through. So the best way to do that is to just hook up a nitrogen regulator. I like the Western Enterprises regulator. It actually has a separate test, which is high pressure, purge, which is like a medium pressure, and then it says BRZ, which means braze, so that you can just easily use that regulator and go between those three. But the point is, you really want to just make sure you're flowing some nitrogen through it at a decent rate, pushing some nitrogen through that entire system, and then making sure that you're kind of flushing everything out before you start flowing nitrogen at the very low pressure. When I say pushing everything out, it's to get all the atmosphere, all the air out, displace all the refrigerant that's in the system as much as possible, so that way you just have nitrogen in the system. Now, some people have asked, how do you know what is enough? Well, I mean, there's not really a good typical way of doing that. You just do it for 3, 4, 5, 6 seconds on an average situation. If you've got a long commercial job where you've got long runs of line that you've done and you fit them all together, and now you're going to be flowing nitrogen, well, then you're going to want to do it for a while, so that way you make sure that now what's flowing through those lines is nitrogen. You can overthink these things. It's not that big of a deal. You just want to make sure that you're displacing the air, moisture, and refrigerant that's in that system, and then replacing that with nitrogen. Once you're then ready to braze, that's when you put it on the flow setting. And so on the Western Enterprises regulator, that's the BRZ setting. If you don't have a fancy regulator, then you have two options. You can use a secondary regulator, which Uniweld makes a secondary regulator. There's a lot of different companies that make it, which is an actual flow regulator. And a regulator like that, a secondary regulator, it doesn't use PSI. It uses CFH, or sometimes it'll say SCFH, which stands for cubic feet per hour, or standard cubic feet per hour. Essentially means the same thing. So it's very, very low flow rates. It's not a pressure reading, it's a flow reading. And so it flows a very, very small amount. Now, if you don't have one of those fancy regulators, don't worry, you can use your regular nitrogen regulator, but you just want it to put out so little that it barely even shows out on the gauge. So what you do is you turn the dial out on your regulator, and you start to turn it in, because as you turn it in, that's what increases the pressure. You turn it in until you can just barely feel or hear a whisper of pressure coming out the other end, the outlet side. You always have to leave one end open on the far side when you're flowing nitrogen. So if you're putting it in one side, you have to leave it open so it can flow out the other side. And so if you just place it up to your ear, you can just hear just a whisper coming out. That's how much nitrogen you want to flow. You want it to be just enough so that it is moving through the lines, but not so much that it's going to blow out your joints. Now, the challenge comes because depending on where your ports are, it depends on what type of brazing job you're doing. If it's a typical, just installing a line set on a new piece of equipment, that's a piece of cake. You just work around in a circle and you get back to the other port and you're done, and it works just fine. But if you're doing, say, something like a reversing valve or a compressor, it can get a little more tricky to figure out how to flow nitrogen, because you don't have an easy way to do that in some cases. And so what you can do is you can flow all the way to the very last joint. And if you can't flow in the last joint, just flow right up to the last second, put the joint together, and then shut off your flow. There's not going to be any error to speak of in the system, and that's okay. If you shut it off on the very, very last joint, it's not going to hurt anything. If someone wants to argue with me about it, fine, but trust me, it's not going to be a problem. So in some cases, you can flow all the way to the last one. But in general, if you're doing a line set on a new system, you can flow all the way around. You just have to kind of think about where you're starting and where you're finishing. But it does always have to be open. You always want to make sure that the circuit, it can relieve pressure. You don't want it to be a closed system, because then as you start to heat it up, it pressurizes. So you want to leave a port open somewhere and flow to that port if at all possible. Again, depends on the system, depends on the application, and it's going to vary slightly. But you want to start by purging it with nitrogen, so that way it's full of nitrogen, and then flow all the way until you just can't possibly flow anymore. But that flow is generally 2 to 3 SCFH, which is just a whisper of a flow. And having a actual flow gauge like a Uniweld, or using the Western Enterprises regulator that has that built right in, just makes it easier to set that. And if you look at a Uniweld regulator, or a lot of the other regulators that have been used for years in welding and brazing, usually they'll have a little floating ball, and basically you just want to barely float that ball. Once you have actually purged nitrogen, so the whole system's full of nitrogen, all you need is just a tiny, tiny, tiny amount of flow. So that's all you need to remember, 2 to 5 SCFH, or if you don't have one, just flow it so that you can barely hear it. And you can generally do this with most nitrogen regulators. It just takes a very steady hand. And sometimes you just don't want to get the pressure too high, because then it's going to be difficult to braze. Your joints aren't going to hold. So you want to flow as little nitrogen as you can, displace the oxygen. I think you get the point at this point. So now comes the question of how you actually set up your torches. And this is an area that technicians do not put nearly enough thought into. So it's important that you look at your torch manufacturer's specifications. Are many of you going to do that? You're probably not going to listen to me. But I'm going to strongly suggest that you understand your torch manufacturer specifications, not just for the torch, but for the different types of tips. Because if you read the specs for the tips, they're going to tell you a lot about what those tips are designed for. And a lot of you are using the wrong tip for the job. Essentially, what you should be doing is, depending on the size of job, you should be going for a larger tip for a larger job, smaller tip for smaller job. But many of you don't do that. You actually just adjust your flame to a more aggressive flame if you have larger copper and a less aggressive flame if you have smaller copper. It's not the best way of doing that, because really you're not supposed to be setting the output pressures at the handle of your torch at all. So if you're adjusting the knobs on your torch actually at the handle, that's not the way that you should be setting the flame by and large. And I understand that it's not practical that we're always going to set it at the regulator, but in general, you want to set it up at the regulator. And that setting is going to be a minimum of 3 oxygen, 3 psi oxygen, 3 psi acetylene, up to 7 psi oxygen, 7 psi acetylene. But the two numbers should always be the same for brazing. So those of you who are taught like me, 7-11, don't do that. Do the same number. Manufacturers of brazing equipment will essentially always tell you that you should use the same pressure for oxygen and the same pressure for acetylene. And then when you light it, they're going to recommend that you light by opening the acetylene a little bit, lighting it, and then opening your oxygen. Yeah, does it create a little bit of, create some bunnies? Sure, but it decreases the chances that you're going to have some flashback into the actual torch itself. It's just a safer way of doing it. I know a lot of you aren't going to listen to me about that, but that is the technically correct way, is to light the acetylene first, and then when you shut off the oxygen first, and then shut off the acetylene. Again, I know some of you won't do that because of the little carbon flurries that you get, but that is the safest way of turning them on and shutting them off. So then what you're doing essentially is, if you have a larger tip, then that's producing more heat. And again, you're setting this actually at your regulator. You're not setting it at the knobs. I know so many guys who just turn those T-handles in on their regulators to put out maximum pressure, and that's not the right way to do that. They should start off with them turned out, not so they fall out, but turned out until they're loose. And then they turn on the tank knobs, and then they just regulate at the handles. I'm telling you, that's a bad practice. So set your regulators, and then when you're done every time, loosen them up a little bit, and then shut off your tanks, and that's going to be the safest way to store it, and it's going to be the best way all around for the longevity of your torches, and also to get the proper heat. So what it comes down to is you're going to need to have a couple different torch tips. So you're going to want to be in the practice of switching torch tips when you're going to large commercial versus small. And I obviously, I know that when you're brazing in a liquid line versus a suction line, is it practical that you're going to switch tips in between those two? No. So you're going to want to use something that works for both, and I understand that. But you want to kind of think about this so that way you're using appropriate heat, because appropriate heat control is a huge part of making sure that you're going to get a good seal without burning through a copper tubing, especially for those of you who are new and aren't really used to to brazing. And so just know your tips, know your torches. A lot of times the tip manufacturers will actually tell you what their desired PSI setting is on the oxygen and the acetylene tanks. So by all means, follow what they tell you. But if you're going to make adjustments, make them at the regulator instead of at the torch handles. Are some of you still going to make small adjustments at the torch handles? I'm sure you will. I understand. But in general, you want to make those adjustments at the regulator. Another question that comes up is, there are different types of regulators even. And so in general, you want regulators. 15 psi delivery regulators are generally what we use for our work. That's the right regulator because we don't really need more than 15 psi output. And it's just always safer to use something that's going to limit its output to the job that needs to be done. So in general, a 15 psi delivery regulator is a good practice for your average HVACR service technician to have. Another thing to mention that is sort of a pet peeve of mine is guys using crescent wrenches or channel locks or anything other than a refrigeration wrench or a dedicated wrench for opening their tanks. So what I suggest is just keep a refrigeration wrench on your tanks. And so if you're going to open and close them, obviously, in most cases, your oxygen, or I shouldn't say most cases, but in a lot of cases, your oxygen will have a regular handle, but your acetylene will have a stem for opening and closing. And that stem, if you use channel locks or any sort of two-sided pliers, you're going to run the risk of breaking it off. And I've seen a lot of guys do that. So use a refrigeration wrench or a dedicated wrench for that purpose. Also, one of my other pet peeves is guys who use, and I know a lot of you you're gonna hate me for this, but guys who use cigarette lighters to light their torches instead of using a proper striker. A striker is designed for lighting torches. A cigarette lighter, your fingers are very close to the outlet of that torch. Strikers are inexpensive. Keep a few extra on your truck. Keep a few extra in your torch kit, but just use a striker for Pete's sake. It's designed for the purpose. They work great, and it's a lot more, in my opinion, it's a lot safer. A lot less likely you're going to burn your hands, and easier to handle as well. I mean, you're not going to use a cigarette lighter if you have gloves on. So if you're brazing like you should be with gloves, then you're not going to be able to use a cigarette lighter anyway. So just get a striker. Use strikers. It's better. It's the way to go. So once you know you have the right tip and you set your regulators to the proper pressure, so 3 and 3 or 5 and 5 or 7 and 7, generally 5 and 5 is probably the most common. Once you get that all set, now it's time to go ahead and light your torches. And like I've mentioned, the proper way of doing that is to open the acetylene first, halfway, light it, then open your oxygen, and then get them both opened until you have the proper flame balance, which should be a neutral flame. And so the way to know that you have a neutral flame, if you look, and this is where looking at photos or actually doing it is a better way to do it, but if you want to look up the two different types of flame, or actually there's 3 different types of flame. There's a neutral flame, which is the flame we want to use in most cases. There's a carbonizing flame, which is more acetylene than oxygen, and that's going to be, you're going to have like a secondary tip. So you're going to have the flame tip, and then you're going to have another kind of tip that fans out beyond that. And then you have an oxidizing flame, which is you go to neutral and then you keep adding more oxygen. So some photos will kind of show you the difference between a neutral and an oxidizing, but it takes a lot of experience to tell the difference between an oxidizing flame and a neutral flame, which is why a lot of techs end up brazing with an oxidizing flame, which is bad. An oxidizing flame has poor wetting properties, and so what'll happen is it makes it more difficult to braze properly with a oxidizing flame. So what you do is you start with a carbonizing flame, so you start with more acetylene, and then you slowly set in your oxygen until that second tip just barely disappears, or maybe just a little bit of that second tip still appears. Again, hard to describe on radio. Just look up the difference between an oxidizing, a neutral, and carbonizing flame. And the main thing you want to know is a little bit of carbonizing is okay. Neutral is even better. That's like a dead perfect flame. Oxidizing is bad. The reason why carbonizing is better than neutral in some cases is that it just proves that you're definitely not oxidizing, because oxidizing equals not good. Another thing to mention, and again, I'm talking about oxyacetylene brazing here, but another thing to mention is what makes brazing different than soldering. So just quickly, anything above 800 degrees Fahrenheit is considered brazing. Anything below 800 degrees Fahrenheit is considered soldering. We still call it solder a lot of cases, so we'll call it, silver solder, or we'll call it braze rod, but sometimes we'll still call the actual rod solder just commonly. But just because you're using something that someone calls solder doesn't make it soldering. It's the temperature that makes it soldering versus brazing, and the techniques are different for the two. But just don't get too hung up on it being called solder versus brazing rod, because you're going to hear those things interchangeably said in the trade. But you do want to think about specifically what rod you are using. And so if you're using copper to copper, you're going to see a few different rods commonly used. You're going to see the cheapest rod is Phos copper, which is just made of copper and phosphorus. And copper to copper brazing, the phosphorus acts like the fluxing agent, if you will. And so Phos copper does work, but it has a higher melt point. It's just not as high quality. The best bet is to use either 5% silver. A common brand would be Silphos 5, Silphos 10, or Silphos 15. We generally use 10%, and those numbers are the percentage of silver that's in the solder. So it still has phosphorus, copper, and it also has silver. And that's a common product to use when going for copper to copper. If you're going to go from copper to brass, or you're going to go from copper to steel, then you want to use a higher silver solder product. In general, I like to use a self-fluxing, so a flux core product or a flux coated product that's high silver, that's designed for that purpose. And like all things in this business, it's best to just read. It's best to know the products that you're using and know what suits a particular job, so that way you use the ideal product for the job. Could you potentially use Silphos 15 for going to copper to brass? Yeah, you probably could, but instead use higher silver and something that is a flux core, flux coated. It's going to be easier for the job. Now, we're not talking about flux. We're not talking about rod selection. We're going to do a whole nother episode. Hopefully, I'm trying to get Harris on to talk specifically about those products. So if I just said something wrong there, just forgive me. But the point is that we're talking copper to copper in general, and that's where you can use phos copper, although I don't recommend it. 5% silver, commonly called Silphos 5, 10% silver, or 15% silver. Before you actually apply heat to the actual connections, you want to make sure to consider what you're working on. So if you have something that you want to protect, like a compressor or a line dryer, or especially an expansion valve, with an expansion valve, you want to make sure that if the bulb is connected to the line and it's close to where you're making a joint, you want to go ahead and just remove the bulb altogether. In most cases, the bulb is going to be a ways away, but just still keep heat away from the bulb, keep heat away from the expansion valve itself, keep heat away from the compressor so you don't burn the paint, keep heat away from line dryers and mufflers and accumulators and all those things to make sure, A, that you're not going to damage them, but B, that you're not even going to damage the paint. Because if you damage the paint or the coating, then it's going to be more prone to rust. So you want to use either wet rags or other heat trap products to keep heat away from those devices, whatever it is that you're soldering in. Service valves is another example. It's always a good idea to have the Schraders out of the system when you're brazing. So that way you don't have to worry about either damaging the Schraders, but then also so you have full flow in and out of them. So that way it makes it easier to flow nitrogen. I should have probably mentioned that before, but get your Schraders out of the system. You don't want Schraders in when you're brazing. So now you've done everything properly. You've got you understand your equipment. You selected the tip properly. You set the PSI on your regulators to the proper setting. You've got everything nice, tight, and clean. You've made sure to follow proper practices so you're not getting any junk in your lines. You've got the proper solder in your hand, and you're ready to work. All right, this is where you want to have some damp rags beside you, maybe a set of channel locks in case you have to handle something really quickly that's hot. I don't know. It's just a good idea to have everything all laid out and prepared. Make sure that everything is protected all around you. You've made all your considerations for anything that could catch fire. You've got your fire extinguisher right there. You got your safety glasses on. You've got your gloves on. You're ready to work. Okay, so now here's how you actually make a proper braze joint. The first mistake, most common mistake that newbies make when they're brazing is they don't get it hot enough, because it takes several seconds. Generally speaking, if your flame is the right size for the job, it's usually going to take 6, 7, 8 seconds to heat it up in the first place, so it gets hot enough to actually start applying the rod to the joint. And that was just an estimate on my part. I've never actually counted. Let's count and see how long that takes. 1, 2, 3, 4, 5, 6. Yeah, I think 6 seconds. That sounds about right. And I just wanted to put you through that boredom. I mean, you listen to a podcast anyway, so clearly you have a pretty good attention span. 6 seconds sounds about right before you want to start actually even thinking about applying solder. Now, back in the day, my instructor at trade school would say, get it deep red. So get it deep red. He would call it dark cherry red, but don't get it bright red. I don't, that's not always necessary. It depends on the type of rod that you're using, but generally if you're using, 10, 15% silver, I find that it's not necessary to get it that red. Generally, I think you're going to get it, that's a little too hot, but you do want to get it hot enough. So make sure that you're getting it hot enough. But where you first want to put your flame, so if you're thinking of the tube going into a coupling, so you have the male part that is the tube and that inserts into a coupling. So we're focusing on the tube here. You want the solder to be drawn into that fitting. So solder doesn't just bridge the edge. That's what a lot of new technicians do, is they don't get enough heat on and then they just keep trying to melt bits of solder on the edge. You want the solder to be drawn into the fitting. So the first thing that you do for the first couple seconds is you get the actual pipe hot. So outside of the fitting itself. So you're actually pointing the flame, if you can imagine this, you're pointing the flame back at the fitting and you're really focusing on the pipe. So you're driving heat through that pipe into the fitting. And then once you actually start applying solder, now you're pointing it back the other direction. So the heat is now on the actual coupling itself, so the female part, and it's pointed back at the actual copper tube. So, and Harris has a lot of really good photos on this. So if you want to look up the Harris website, you can find some photos on exactly what I'm saying. But just imagine the tube. The tube is the male part, and it's going into the female coupling. So you start by pointing it at the coupling, focusing the heat on the tube. That way the tube is getting hot and heat is transmitting inside that coupling. Then you start applying solder, and now you point it back the other direction with the heat concentrated on the actual coupling to make sure that you suck as much solder as possible into that coupling itself. Then once you get done, you want to do, and this is some people will tell you differently, but in general, I want to make sure that you have a good fillet. That's the term that we use, or a cap on the actual end of it, to make sure that you can look at that fitting and know that it's not leaking. So where that coupling covers the copper, you don't want to see any gaps or crevices around there. You want to just make sure that that's nicely coated in a cap of rod. Only once you know that you've pulled solder into that joint. You've pulled the brazing rod into that joint, so it's sealed the whole thing. So you seal the whole thing, and then you make sure that you have a nice cap on it. Then that's when you take your mirror and you make sure that it's all nicely sealed. There's no cracks. You always use a mirror and look at the entire fitting before you do anything else. And now let it cool naturally. Now this whole time you've been flowing nitrogen at very, very low amounts. You've been using 2 to 3 SCFH, or cubic feet per hour of nitrogen. So you've been flowing at very low rates this entire time. Now let it cool naturally with the nitrogen flowing. That's going to do a much better job of preventing any carbon from building up inside the lines, because that's the reason that you do it. That's the reason you flow nitrogen. I didn't talk about that because we talk about this in other podcasts. We've already talked about why you flow nitrogen, but that's why you do it. You do it so that you don't build up carbon inside that line, because if you look at the outside of the line and you get these nasty carbon flakes on the outside, if you don't have nitrogen flowing or some inert gas flowing through that line, then you're building up that same nasty carbon inside there, which can go get stuck in electronic expansion valves or cap tubes or whatever else, which is all nasty stuff. And there's lots of reasons why our forefathers in the trade didn't used to worry about it as much as we need to now, and I'm not going to go into all those, but it's an important thing, and it's something you need to be doing as much as you possibly can. But in addition to that, let it cool with the nitrogen still flowing. Don't jump straight to throwing a cold rag on it or anything. Just keep moving down the line and making more joints. Then once you're all done, they've all cooled, the last one is sealed, the nitrogen is shut off, that's when you do a final inspection on all of them, make sure that everything looks nice and sealed, and now you nitrogen pressurize back up and you do a bubble test on all the fittings that you just created before you go covering them in Armaflex or anything. I've had a lot of installers tell me, well, I'm just that good. I know they're not going to leak. Pressurize it up with nitrogen. Depending on the system, that's going to dictate how much pressure you use, but pressurize it up with nitrogen to the safe level, and bubble test all those joints and check them all with a mirror. Make sure that you've done the right thing, because this is quite a thing. I mean, setting this all up and flowing nitrogen and putting on your safety gear and all this, you want to get it right the first time. There's nothing worse than not getting it right the first time. And again, for the newbie, the mistakes they make are not following proper safety procedures, not reading the manual for their torches and making sure that they're using the proper tip, and then ensuring that they're using enough heat to get the job done quickly. But what damages probably more components, reversing valves being the worst. In Florida, we have a lot of heat pumps, so we have these reversing valves, and they've got 4 connections on them that are all really close to each other. Again, this isn't an episode on how to do a reversing valve. If you're going to go do a reversing valve, talk to an old timer, and they'll give you some tips to do it before you go jump into doing that job. Expansion valves and compressors and line dryers and all these things that can be damaged by too much heat. It usually doesn't happen because there's too much heat one time. It's because they're on again, off again, in and out, in and out, in and out with the torches. There's no reason to be in and out with your torches. You regulate the distance between your torches and the fitting just in order to control your heat. And a lot of times you do this because you may have a little more heat than you need, and so you're backing off just a little bit, because this is sort of natural. Like if you're using the same type of tip and the same flame in general to do your liquid line and your suction line, say on a new system install. If you have the flame set perfectly for, say, a 7/8 fitting, well, that same flame is going to be a bit too much for 3/8. So either you can alter the time so you can just work more quickly, or you want to back off a little bit to make sure that you don't overheat the fitting, because you don't want to get it. As soon as you start to see a fitting or copper or anything start to turn bright red or even cherry red, I don't think you need to get to that point. You want to back off so that you're not overheating it, but you don't want to back off completely. I see so many techs that they'll start to braze, and then they'll back off and think about it for a little bit and then go back in. Damaging something like a liquid line service valve or a suction valve is a factor of how much heat are you getting on it, and then how long are you getting the heat on it. So first of all, by using wet rags or some sort of heat trap product, you're keeping it cooler. So that's an important part. But then also you don't want to use way more heat than you need, but you also want to make sure that you get on it quickly and get off it quickly. Get done as quickly as you can. I see guys, they use a little rod and then they take the mirror and they check. And then they use a little rod and they take a mirror and then they check. That's not how that works. You'll notice I didn't overstate all the techniques of holding the flame and all this. It's very simple. You put most of the heat on the pipe pointing towards the fitting. Once you get to the point that solder starts to flow, then focus your heat the other direction. Don't overheat any one spot and burn a hole through it. That's all you need to know, really. Don't overthink it. On big copper, obviously, the larger the copper is, the more you have to move the flame around to distribute the heat all the way around while you're brazing. But you don't want to be moving the thing all over the place. An inexperienced brazier is a guy who's constantly moving his torch all over the place. It's just not necessary. Obviously, if you're starting to overheat a section, then you move it a little bit, or if it's not flowing in one section, you need to move the torch to get heat into that section so that you can flow. But get in, get out, get it done. And the best way to do this, frankly, for those of you who are new to the field, if you're an apprentice or whatever, just there's no replacement for getting a set of torches, knowing your torches, reading up, getting all your safety equipment, getting everything ready, and then just plant a bunch of pieces of copper tubing in your yard and start going to town and doing all sorts of brazing. Any technician who talks to me and says, "Oh, I want to learn more about brazing. I'm not good at brazing," the question to ask is, all right, well, when have you practiced? Well, I haven't had much of a chance. What do you mean you haven't had much of a chance? I'll give you as many fittings and pieces of copper as you want. Go home, plant them in your yard. Yeah, make sure to follow proper safety procedures. Use safety glasses or goggles and gloves, and go at it though. Learn, practice. That's what it takes. Just practice. But don't go moving your torches all over the place for no reason, and don't keep going in and out on the piece that you're working on. The only reason to back off is if it's overheating. I feel like I'm saying the same thing over and over, but this is really what you need to hear if you're new to the business. So finally, once you've applied nitrogen pressurized, bubble tested everything, check everything thoroughly with a mirror and a flashlight are a great thing to have for checking all of your fittings. Make sure you don't even see any little micro bubbles. You're just checking everything really well. Now you're ready to go ahead and pull your micronic vacuum. And while we do not use a micron gauge to check for leaks, that's not its design, it does help you check for leaks. So the final step in a properly performed brazing job is to make sure that you have no leaks. Nitrogen is layer number 2. Layer number 1 is visual inspection. Nitrogen and bubbles are layer number 2, and then layer number 3 is pulling a micron vacuum. Once it's all done, you valve it off at your core tools, because that's, we've talked about this ad nauseum. You have your core tools connected and your micron gauge is connected to the side of your core tool. You valve those off and you make sure that your vacuum doesn't keep rising. And there's different reasons why vacuum can rise. It can be moisture, it can be leaks, but you want to make sure that it doesn't continue rising above a certain decay rate. Again, another podcast, but that helps you ensure that your braze joints are tight. So, in final things to go over here. Safety is very important. You want all of your braze joints to be visually confirmable as not leaking, which means that they have a nice cap around the whole thing. But the cap is not what seals your braze joint. What seals your braze joint is drawing solder into it. Don't overheat a single spot, but that just takes looking at it. Most guys who I see who are poor brazers are nervous brazers. So they're always nervous that they're going to burn through the copper. You're not going to burn through the copper if the copper is not getting red yet. So you don't have to worry about that. As long as you have the proper heat, you're also going to reduce the chances that you're going to burn through your copper. Yeah, if you're using a gigantic torch tip, and you've got it set to, 2020 on your regulators, and you're just dumping tons of gas at it, and you try to put that on a 1/4-inch line, well then yes, of course you're going to melt through it. But if you're sensible about this and you know what you're doing, you're not going to melt through copper. Most technicians don't apply enough heat. Flow nitrogen. Don't pressurize with nitrogen while you're brazing. Make sure to purge nitrogen first before you flow to make sure that you've displaced all the atmosphere as possible. Only braze on an open system, so meaning that there has to be a port open somewhere to braze. Otherwise, when you heat, it's going to become pressurized. Don't unsweat fittings if you can help it, because you run the risk of setting the oil on fire and creating a mess. Always think about the space that you're working in. Use proper safety equipment. When you're setting your regulators, set them to the same pressures, generally 5 and 5, but can in some cases be 3 and 3, 7 and 7, maybe in some rare cases 10 and 10. Read your manufacturer's information. Change tip size based on the job that you're doing. You don't use the same tip for a 3/8 line that you use for a 2 1/4 line, or 2 3/8 line. Use a separate tip for those jobs. They're different jobs. Understand your tips. Keep a mirror and a flashlight. Confirm with soap bubbles. Pressure test. And then use a vacuum as your final proof that you have a system that is totally tight. All right, that's it. Those are my top brazing practices. Thank you for listening to the podcast. I know it's been a while since I've done this type. I'm interested to see if you think this is helpful. I think for those of you who do a lot of brazing, of course, this is going to be preaching at the choir, and some of you are going to say that I'm being a little overkill on some of the things that I say, but I want this to be something that you can share with new people who are coming into the business. And I think it'll be helpful for an apprentice who hasn't done a lot of brazing. But listen to me carefully, Mr. Apprentice, who's riding along with the senior technician and has dreams of grandeur. If you don't practice, you don't learn. And if you're not going home and practicing by sticking some of these things in the dirt and working on it yourself, then you're proving to the guy who you're working with that you don't really have a deep commitment to learning. If you want to learn it, you can learn it. It's not that hard. All right, thank you for listening to the HVAC School Podcast. As always, you can get great discounts on all sorts of great quality tools. Testo tools are some of my favorites right now. 605i, the Testo 550, 510i. There's all sorts of great products, but you can find them all by going to TrueTechTools.com. Use the offer code GetSchooled for currently an 8% discount at checkout, which is probably one of the best prices you're going to find anywhere on some of these products. Thank you to HVAC-hacks.com. That's Ralph Harmon's website for sharing the podcast and being such a good partner with us. If you want to see the way not to do it, go to HVAC-hacks.com. And those guys remind you, don't be a hack. I want to remind any of you who have seen my Beer Can Cold t-shirt, those are still on sale, and I am not advocating for Beer Can Cold as a way of actually testing a system. It's just a little inside joke in the industry. So many guys that I rode with would grab the suction line and say, "Oh, Beer Can Cold, you must be charged properly." It's a joke, people. It's not how you charge a system. Thank you to Testo. Thank you to Carrier. Thank you to Rector Seal. And most of all, thank you to you for listening and sharing the podcast. We had a record month in June. It's amazing how many people are listening to this podcast. And I give credit to the fact that I think technicians, many of you like to pretend like you don't care about your jobs, but I suspect you do because you're listening to stuff like this. Thank you for being who you are, and keep the faith. I think things are looking up for the trades. So get back to work. I'll talk to you next time on HVAC School.